Okay there, hi everybody, it's Mr. Burgess, and today we're going to take a look at science experiments, how to do pure science and get an A plus in the process. So this week we've had some pretty cool experiments happening at home. I'm going to highlight a few student experiments. So first was Espen. Espen did the classic vinegar and baking soda investigation. He mixed it together. He wanted to know, will the bag explode from the air pressure when he decided to mix these two chemicals together?
Hey, I'm doing the vinegar and baking soda bag challenge, and I think this bag will explode.
You don't want to say challenge because it's not a challenge, it's an experiment. Take it up. Okay, taking this to the next level. Um, it's cool to mix stuff together, and a lot of really important discoveries have come from experiments that were pushed a little bit further. So maybe the scientist saw something, observed something. Maybe they weren't even trying to do an experiment. They just saw something that's kind of sparked their curiosity, and then they decided to put it through a test. So I thought, well, could we test the strength of the reaction? Could we test the amounts of the products made in the reaction? So for example, I had a question. I wonder how much mass a reaction of vinegar and baking soda can lift. Could you put something on top of the container while it's starting to react that tries to sort of block it from reacting, right? What's the maximum amount of weight that the reaction could lift off of your container? That'd be kind of cool. I was also wondering how much gas this reaction produces. So if you mix vinegar and baking soda, how much gas can be produced in the reaction? But the key to a successful science experiment is you can only change one variable. That means in your experiment you have to keep absolutely everything the same container, same ingredients, same amounts of ingredients, but you can only change one thing. So for example, here's an example experiment. Experiment 1. Change the mass put on top of a container. Keep the amount of vinegar and baking soda the same each time, and then just keep adding mass. Start with something light on top of the container. It could be maybe you have an old deck of cards where you're missing some cards, and you just start by maybe putting 5 cards on the top of the container. See if it'll lift it off. If it does, maybe try 10 cards, and then move it to 15 and see what the maximum number is. Experiment 2, this would be a totally different experiment that was going with that previous question about how much gas could be produced. In this experiment, keep everything the same except change the amount of baking soda. Keep the amount of vinegar the same. See if it produces different amount of gas. Capture the gas in a balloon and measure how much gas is in the balloon each time you run the experiment. If you change just one thing, in this case, change the amount of baking soda, perhaps you would get different amounts of the reaction happening, even with just keeping the vinegar the same. I don't know, we'd have to try it. Okay, moving forward, we had Faith. Faith did the classic milk stone experiment. She even took pictures of her experimental setup. Very cool, she had it all laid out there very neatly. She recorded her procedure and then even had step-by-step pictures that she took until she revealed the milk stone. Observations listed really clearly and had a written conclusion. Very impressive write-up. Same with Shayna. Shayna had her write-up. She did it on paper. I took a picture of it. And then she had this line here. First I got 1 cup of 2% milk. And then she said, you can do 1% or 2%. It does not matter. And I thought, well, how do we know that? She got Milkstone. Here's a picture of her incredible milk stone. But I thought, that's a good opportunity for a test. It made me think, could you make milk rock that was stronger? Could you run an experiment to test the strength of it? I wonder how much mass milk rock can hold before it breaks. what about the amount of milk rock? And this goes back to Shayna's statement there. Does it matter if the type of milk affects how much milk rock forms? Does 1% or 2% change how much rock you'd get? And again, here's a couple example experiments where we're just going to change one thing. Experiment 1. Make a molded rectangle of milk rock. Span the milk rock across a gap between 2 chairs or 2 tables or 2 books or anything. Keep adding mass until it breaks. Maybe you have some coins at home and you just keep putting coins on it until it breaks, or something small. Measure how much mass your milk rock can hold. Experiment 2. Change the types of milk used, so we can keep everything else the same. The amount of milk, so the amount of time you're heating the milk, the amount of vinegar that you're mixing it with. But you could use 2%, 1%, coffee cream, whipping cream, homogenized milk to try to make milk rock. Weigh the results. So if you keep everything the same amount of milk or cream, maybe you would get one rock that's the heaviest, makes the most milk rock here. A couple other experiments to highlight. Connor made oobleck, and his hypothesis: will he mix it to make oobleck that will stop the strong force of my hand if he punches it? Let's take a look. Punching is one way, but could we do this in a different way? Could we actually test the strength? Because I don't. Connor's punch is probably pretty hard, but I don't know how hard it is. So I was wondering, does changing the recipe of oobleck change how quickly an object sinks in it? We're going to just change one thing. Here's an example. This is just an example experiment. You could do your own sort of test. But here's experiment 1. Change how much cornstarch you use. Make several batches of oobleck. Keep the amount of water exactly the same. So maybe in the first one you do like 3 tablespoons of cornstarch, and you just mix it with this with a measured amount of water. But then the next time maybe you go 4 tablespoons of cornstarch, or you drop it and go down less, 2 tablespoons. Use an object like a coin and time how long it takes to sink in your different recipes of oobleck, and that way you'll be able to test kind of what the coolest combination of cornstarch and water is. Okay, and one more experiment. Kala did an egg and vinegar experiment. This one was super cool. The hypothesis is the egg will become bouncy, or will it become like hard boiled if she mixes the two together? Let's take a look. Okay, the bouncing egg. Right away when I saw this, I'm like, that's so cool. I wonder which, if you were to change the egg, like if I had a homegrown free range egg versus some of the generic brand, cheap eggs that you can buy, would there be a difference in which one bounces higher? I wonder, do different kinds of eggs bounce differently? That could be one experiment. So kind of testing the bounce. What about testing the maximum height? So even if you just had one egg, I wonder how high can an egg bounce? So in these example experiments, we would just change one thing. So experiment 1, we're going to try rubberizing several different types of egg to see if the effect is different. So you're using the same amount of vinegar in this case, but with different eggs. We're just changing the type of egg that you're dipping in the vinegar. Then you would drop each egg from the same height and measure how high they bounce. So we're keeping everything the same here, just changing the type of eggs that you mix with vinegar. Experiment 2 is about the height of the drop. You're just doing one egg here just to see what's the maximum height you can get from an egg. So you drop an egg from a short height, not too high from the first one because it might shatter, and then like, I don't know if I could have gone lower than that. Continue increasing the height until the egg begins to fall apart. Be careful to measure the heights accurately each drop. So start with like a short distance, maybe only a few centimeters, and then increase it until you get to a maximum height. And then you're actually doing, you're pushing your science beyond just mixing things. You're actually measuring things. And that's, I think, really key to an A+ experiment and how to get yourself to that A+ is that when you're doing pure science, it's a test that you can measure something, whether you're measuring a mass, a height, a volume, and you're only changing one thing. One thing varies. That's why it's called a variable. It varies from one experiment to the next. Okay. Thank you for watching. Go and get your hands dirty. Do some science.